And welcome back. In this video, we're going to check out some silent errors, and we're going to use a small data set that looks like something that you might get from a vet clinic, and it has a loyalty program. So think about some kind of an export with loyalty program fields. So we are talking about silent failures here. So the first one are string numbers sorting wrong. And in just a second, when we take a look at the data set, you'll see that it has numeric looking IDs. And as you'll see, the ID averages are going to result in meaningless data, so noise. And we also have text timestamps that break grouping. And this is exactly the kind of data set where types, or data types that should be more exact, can go wrong. Not necessarily because you made a mistake, but because exports often don't preserve meaning. So let's say these three classic silent wrong features are going to be: first, numbers stored as strings incorrectly. And if you see here, it says the numbers sort wrong. Well, that's because you're getting 100 before you get 20. So 20 should come before 100. So there's our first flag. Number two, the IDs get treated like measurements and produce meaningless averages. Like, why do we need averages for an ID? So that's introducing noise into our data set. And finally, number three, the timestamps are stored as text, which makes grouping a little awkward and fragile. And here you can see that it breaks the grouping. So just remember that the best option usually isn't do more analysis. It's validate and correct types before trusting any metric. All right, so here is the Colab notebook. Let's go ahead and run this first one here, and we'll talk about this, but just remember that if you are clicking the link below this video and you want to save it, you're going to have to go to File and save a copy in Drive. Or you can download it as well if you're using a local version of IPyNB, which is Jupyter Notebooks, or you could use a .py file if you want to use an IDE. Okay, so what did I import here? We've been working with pandas and NumPy because pandas is how we work with spreadsheets and do data manipulation, and it's built on top of NumPy. But what is RE? This is regular expressions, and you can see a little bit of these sort of numbers here. This is something that we're going to use, and I will explain it as we go through this example. All right, so here's our demo data set with 3 failures. So let's see what we have. Well, actually, let's go ahead and run this. Okay, let me just look at the whole thing here. I'm just going to use df_raw. Okay, so this is a very short data set, so you can't even use the first 5. So if you want to look at the first 3, for whatever reason, just remember you can specify that here. But I'm not going to use anything because we have such a small data set. All right, so here we have the customer IDs, which do look like numbers. And then we have zip codes, and this is a little bit of a gotcha here, and I'm going to explain why. So these are a little tricky, and these look a little tricky too, and that's why we call these silent errors. And here's the plan here. If you're good at EDA, you probably noticed, hey, this needs to be handled. And here, same thing here. Look, they should all be normalized. Temperature, okay. We got some floats, we got some integers. So we need to make sure that we can classify integers, floats, strings, what type of data. And this one, what kind is this? If you said datetime object, that is correct. And here we have yes and no, which is Boolean. This could also be 1 or 0 or normalized. Visiting notes, we said that notes are what kind of data type? Unstructured. So just keep that in mind. And here we have key value pairs, right, for the device. And here we have some kind of media. I know that because it's a .png file. So here we have a path, and here we have a blob, which stands for binary large object. Basically, these are raw bytes for things like files, images, and audio. So for large binary objects. Okay, and so here we have the 3 silent features, and this is where we're going to do this together. And that's what we're going to do in the next video. All right, so now we need to fix all of these problems in our data set. What would be the first step? Go ahead and pause the video, think about it, and when we unpause, I'll share some of the first few steps that we could take, which does not mean that that is the only step you can take. There are many ways of doing this. I just want you to kind of think about, like, okay, I have the data set. How would I handle this? All right, so the first repeatable workflow might be to use or inspect with the .info or the .types, right? In this way, we can look at and know what the tool actually thinks that the types are. So we need to know what the data types are, make sure that we have the correct one, and we can get a little bit more information with .info. And then we can do like conversions, which is pretty straightforward, especially when you're working with numeric data. And let's say that we want to convert something to a numeric value for money. Then we could use the to_numeric method, or we can use this method, which is to_datetime for timestamps and a map for yes and no Boolean values that we talked about. So we'll look at those values. And we can also create an optional category for repeated labels like tiers and zip codes. And we could use this category data type here. But that's not all. Third, we need to verify by rerunning the same actions that were initially broken. So we need to validate. So that means that sorting should behave like numbers. And that means also that averages should work only for real measurements and not for IDs. And grouping should be by month. And grouping by month should be clean and reliable. And just remember, when you're considering the best option pattern, when results are weird, fixing data types before you trust any metric is not a bad idea. And more importantly, this is how you prevent quiet wrong dashboards, which you never want to do. If you have silent errors, find them. That's okay. That's pretty normal. Like we said, real life is messy, so the data is often messy. But you don't want to let that pass through you and end up in a dashboard and you're in the middle of a presentation and you're just saying things that are completely inaccurate. While that might be an innocent mistake, the danger there is you have built trust with your team. So you want to make sure that you have all of the numbers correct before you say something that undermines that trust that you've built with your team. But before we do that, we get into fixing, we need to understand what are the data types. So maybe we can have some kind of a checklist. All right, let's do this with a numbered list. Okay, number one is going to be int. This stands for integers or whole numbers, like 42. In short, these would be counts or quantities. IDs sometimes look like integers, but they're not measurements, and that's where it can be a little tricky. And another number would be a float. These are measurements with a decimal, so you could say 3.14. That would be a floating point number. This would be also helpful for money, weights, duration, and if you average it, it could be a float. So floats are very useful for continuous values, and we'll talk about that a little bit for continuous values or values with a decimal. And if you wanted to convert money, you could use to_numeric, and we'll do that in the example in the next video. In number 3, we saw that we had bool values. Right, so these are essentially true and false, but you can also write them as 1 or 0. And you don't want to get the average of a Boolean because it will give you back a rate, and that's not what we want to use that for. But we can map this. So we can map yes and no to true and false. And there are other techniques, but generally when we're dealing with a bool value, true and false, you want to watch out for the average of a Boolean value. And instead maybe consider mapping. And number 4, we're going to call this a string, but it's also in pandas called an object. So we can call this a string or an object. And these really just translate to text or labels. And these are great for grouping and terrible for math. Most of the common source, and I would also say that strings and objects are the most common source for strange metric behavior because it's not numbers, right? They just look like numbers. And we'll demonstrate an incorrect sort, and then we'll fix it in the notebook when we start to fix things. And number 5, we have datetime, because you can't work with datetime objects if they're just numbers, right? So we could call this datetime is time intelligence, because you can do stuff with time. But if you don't have the right datetime object, then it's going to be very difficult. Let's say you want trends, cohorts, or month-over-month information. You're going to need a datetime object in that case. And we can parse and convert date stamps, right? And we'll do that in the next video. And number 6, I said that we can use an optional category. But what is a category? You can think of these as compressed, repeated labels, like days of the week. Or if you're using a very small vocabulary columns, or it could be tier, state, maybe a zip code, right? And we can use the as type method to change these and use group by. We'll do that in the video next when we're cleaning and fixing this. In number 7, we have blob. And I mentioned that blob means binary large object, and it's not table shaped, right? So it's not analysis ready, meaning it needs to be extracted and flattened before it can be analyzed. And I'll show you a JSON-like column that gets flattened, right? And then you can use that for a table-like shape. All right, and on that note, we will fix this data set next, and we'll identify all of these data types that are inside of this data set. See you there.